Alright, so the continental drift theory. Plate tectonics accounts for important features of Earth's surface and major geologic events. Now, the thing is that it actually moves, and we have a theory called the continental drift theory. So Alfred Wegener is the one who came up with this theory. He noticed that the continents seemed to fit together, not perfectly, but kind of, like a jigsaw puzzle. One single landmass called Pangea is what he called it, and he estimated that it started splitting about 180 million years ago. So maybe you've heard of the word Pangea before, but that's what he called it. Rodinia is the name of the supercontinent that existed about 500 million years ago. So that is actually what happened before Pangea. Just fun fact for you. Plant and animal fossil evidence was also a reason why he came up with this hypothesis, which we're going to take a look at in a second. It also had rock evidence as well. All right, so this is what he thought it would look like 245 million years ago, and then 135 million years ago, and then 65 million years ago, and of course what we have today. So this is what Pangea kind of looked like. And you can see all those, continents kind of fitting together. That was 225 million years ago, then 180 to 200 million years ago, then 135 million years ago, 65 million years ago, and of course Earth today. So if we go backwards, it's kind of cool. And then you can go forwards. Okay, so Earth today that's what it's looked like, but it did look like that. Alrighty, so we got fossil evidence. Climate and location of continents throughout history. Our first example is the Mesosaurus. It's a reptile. It lived about 250 million years ago. It had freshwater lakes, ponds, and rivers. It could not live in the salty ocean water. And the fossils of the Mesosaurus were found in South America and Africa. So there's no way that it could have, swam across the salty ocean to go to, South America or over to Africa. There must have been something where South America and Africa were connected. So think about how could this be? So the Mesosaurus is, the fossils were found where the purple areas are, which is right here and also right here. And the Glossoparus is a plant, and its fossils were found where the green parts are, which is right here in South America, Africa, Madagascar, Australia, and Antarctica. So the Mesosaurus can't live with salty water, and I don't think a plant got up and moved to all these continents or took a, delta flight all over the world. No, I don't think that happened. So, Alfred Wegener started thinking about this. There's a bunch of other things that we kind of saw as well, or Alfred Wegener saw, is this land reptile right here is in brown, so its fossils are found right here. Again, the Glossoparus is in green, the Mesosaurus is in this bluish, and this other one right here from the Triassic area is in South America and Africa. So kind of weird to think about. We're going to do this a little bit later, but we kind of already talked about this with deposition, so this is just kind of a review. But he also did notice that the youngest fossils were near the surface, and that if you wanted to find older fossils, you would go down, 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 way down here, which is exactly what he did in order to find those fossils. How does fossil evidence support Wegener's theory or hypothesis of continental drift? So read those very quickly. Alright, it's not C, it's not B, it's not D, but similar fossils found on far apart landmasses suggest that the continents were once a single landmass, which of course we know is called Pangea. Sadly, most scientists did not accept Wegener's hypothesis because he could not explain how something as large as the continents could be moved such a distance. So even though he had all this evidence, he could not explain how, South America was, at one point really close to Africa and all these things fit together. How could these big land masses move? So he actually froze to death in 1930 during an expedition crossing the Greenland ice cap, but other people continue to gather evidence. All right, so the breakup of Pangaea, we've kind of already looked at it, but we can look at it again. So as we go further and further along, all the way up to present, we can see that now we are, really far apart, whereas before we were really close, and you can see those things were kind of matching up together because, they were really close together. They were like neighbors, and then all of a sudden it's like this big river came in between them, and they're really far apart now. All right, and this continental drift, which you can't really see. But it goes really, really quickly, and it breaks apart to what we have today. So it's really kind of cool looking, which is what we did before. Okay. All right, more important discoveries. In the 1950s, rocks on the ocean floor were younger than the rocks that make up the continent. So people started collecting evidence. Even though Alfred Wegener was dead, they were trying to figure out, well, that does make sense, so let's look at some other things. So they saw that rocks on the ocean floor were younger than the rocks that make up the continents, which they thought was really kind of weird. In the 1960s, Harry Hess hypothesized something called seafloor spreading. And then it was found that the ocean rocks get older and older the farther away they are from a crack, which is like the mid-ocean ridge. So they called it seafloor splitting. The mid-Atlantic ridge, which is actually in the Atlantic Ocean, this is where seafloor spreading occurs all the time. New ocean floor forms, and it may build above the sea level and create an island. Plates are moving away from each other, so older crust moves out, and then the new crust kind of comes in. All right, so this is kind of what it looks like. Hopefully this will work. Okay. Let's see if it'll move or not. Okay, I think I have another one in here, so don't worry about it. All right, so this is what happens. So this is seafloor spreading. So we know that magma and things like that are in the asthenosphere. It causes everything up here to move on the lithosphere. It comes up, and what happens is that magma cools and hardens to make that igneous rock, and then it pushes all this other older crust out. So if you want to think about, I love jelly donuts. So when I was younger, I used to squeeze the jelly donuts, and the jelly would come up out the top of the hole that it puts the jelly in. And then all the old jelly would kind of run all over my hands, and my mom would yell at me because I was so sticky. But the new jelly is near that crack, and then all the old jelly would run, further and further away from, the actual hole where the jelly was put in. So if there's a question that asks you, where is the older crust, you would say really far away from that hole because there's new jelly or new magma coming up through that crack. So you can look at this if you want to. All right. They also noticed that there was a magnetic reversal in the ocean. You don't really need to know about that. But then the normal polarity would go this way, the reverse polarity would go that way. Don't worry about it. So with all this new evidence, all these other scientists that were working towards Alfred Wegener's theory, it became a theory in the 1960s because of all of this other evidence that was found. So he was, yes, very happy about that, even though he died, being frozen to death. So that kind of sucks. But he was happy because, now his hypothesis became a theory. Alrighty, so we're going to look at this a little bit later, but hopefully you know a little bit more about continental drift theory and know, what Pangaea is and things like that. So hopefully you got your notes filled out. Make sure you bring it tomorrow, and I will see you then.